All right, this video is for my Calculus 1. It's my optimization review lab, and I'd like to do number 7. Before we start, I have cubic centimeters there, but we're talking about if 1,200 square centimeters of material is available to make a box with a square base and an open top, find the largest possible volume of the box. So I hope you see right away where I shouldn't have said cubic, because cubic is volume, and they gave us the material, which is surface area. So let's draw the picture first. So we have a square based box, and when they tell me the box is square based, I always call it X by X. And they don't say anything about the height, so let's put it there. And they said it's open top, so here's my open top, okay? So it says I need 1,200 square centimeters of material. So they gave us our constraint, which is our surface area, if you will. Our surface area of all the sides. And the objective is they want the largest possible volume of this box. Okay? So first of all, let's do our surface area equation. And if I were to kind of go down like this, okay, the surface area is I have a base. So here's my base. And then I have 4 sides. So I know my area of my base is x squared plus each side, if you will. Let's look at this side right here. Is the area of that is x times h. And if I go all the way around, they're all going to be the same. So that's going to be plus 4 x times h. And I know that has to equal 1,200 square centimeters. They said that's all they got for material. So I actually solve for h because it's a little bit easier because x is squared. So I have 4xh equals 1,200 minus x squared. And I'm going to divide by 4x, the whole thing. So when I do that, 1,200 divided by 4x minus x squared over 4x. I'm doing this just so you can see all the steps. When you do that, you get, well, 1,200 divided by 4 would be, let's do that. 1,200 divided by 4 is 300 over x minus, and then this x is gone, so I have x over 4, or 1/4 x. You could write it like that. It doesn't matter. So we're just going to leave it like that. Now, my objective, obviously, is my volume. So I want to have a largest possible volume, so we're doing our max volume. So I know volume of this is area of the base times the height. Volume is x squared times h. So on the h spot, I'm going to put this whole thing right here. So my volume is x squared times 300 over x minus x over 4. And then I'm going to distribute that right here and here. So I end up with 300x, okay, because this will cancel out and leave 1 there, minus x squared over 4. Oh, excuse me, x cubed over 4. Sorry. There we go. There's my volume equation. I'm actually going to write it like this, and I think you'll see why in a minute. 300x minus 1/4 x cubed. Okay? So there's my volume equation, all in one variable, and it has our constraint already in there because we put it in there by plugging it in the H spot right here. Okay? So we have to find the max volume, so I've got to do V prime. And when I do V prime, I get 300 minus 3/4 x squared. Put that equal to 0. So I've got 3/4 x squared equals 300. Multiply both sides by 4/3. I get x squared equals 400. And then I take the square root of both sides, which is really plus minus, but you don't need to do that if we're talking the size of a box. So it's going to be 20 centimeters is the side of the box. So our height Well, let's check to make sure. Remember, we always have to check our V prime. And I put 20 here. And what I would do is put this in our calculator right here. No, I forget I just said that. Right here, sorry. I would put that in my calculator and look to the left and right of 20. And when you do that, you're going to get plus here and negatives here. So this is truly a max. And then I'm going to plug in the 20 into the H spot. Okay. And when I do that, H comes out to be 10 centimeters. So make sure that you plug in the 20, show that you're doing this, okay? So basically, they want to know the largest volume of the box. So I have 20 centimeters. This is 20 centimeters. We just found it. And this is 10 centimeters. So the largest volume is going to be length times width times height. And when I do 20 squared times 10, you're going to get 4,000. Now that's cubic centimeters. So I hope that helps you out, and I'm sorry about the mistake.